at ILVO lies in line with her strive towards a sustainable society. She works at ILVO for over 3 years now, where she focuses on emission monitoring in livestock housing. Her presentation is Emission Impossible, the Road to Standardization of Emission Monitoring of Livestock Housing. So, Anne, if you want, the floor is yours, and you tell me when I have to change the slide.
Sorry, Hans had the hand raised. I think that it's because he's started recording.
Yes,
Hans?
exactly. Just wanted to let you know that this webinar is being recorded. So if you do not wish to be visible in the session, then you should not use your camera. That's all. But the session is actually being recorded. Thank you.
Okay, now we have these technical issues done. Let's focus, or let's go to this action, to the mission possible or impossible. And our main character is here Farmer Joe. Farmer Joe has a pig barn. He's concerned about the welfare of animals. He's also concerned about his environment. His pig barn is located in Flanders, where you have a scattered landscape of natural habitats surrounding his farm. He knows that from the barn, and especially from the manure pit, there is ammonia that leaves the barns through the exhaust, through the ventilation, and he wants to know what is the amount of ammonia that comes out of his barn. But there are some considerations he has to take. These ammonia measuring systems, these ammonia sensors, they should be affordable, they should be accurate, they preferably measure continuously, so 24 out of 7. This is because when he sees a sudden increase, then he can act directly and change his management to adjust this increase in peak. And the last but not least is that the sensor should withstand the conditions inside the barn. We know that ammonia can be a corrosive gas, so it can impact the. Can you go back a bit, or? Yeah, we know that ammonia is a corrosive gas, so it can have an impact on the electronics of your device. Should then Farmer Joe to go to the team of Tom Cruise? Is this a mission impossible? No, I don't think so. He can go to our team, to the team at ILVO. So ILVO is the Flanders Research Institute for Agriculture, Fisheries and Food. It is, we are focusing on everything of agriculture, and we are funded on the one hand by our government. So we do a lot of research on the request of Flanders. On the other hand, we also have a lot of ongoing European research projects, and one in particular I would like to mention now is the Nutritive project, because it lies a bit in line with the ESNI. It's also about nutrient and pollution of nutrients across the whole manure chain. Now let's focus on our group. So our team is the Environmental Technology Group, and we focus on emissions from barns. What kind of emissions? Dust particles, greenhouse gases, ammonia, as well as odor emissions. This group has experience for over 10 years now in barn measurements, but we expand our knowledge, and now we also explore or have projects ongoing which also focus on measuring emissions from manure processing, and also when you apply manure on the field, how and can you measure emissions. Okay. Now, how do you start with measuring emissions? It has been asked to me as well. Do you know something about the Vera protocol? Let's first state what Vera is. Vera is an is an initiative from different European partners. It involved Flanders, the Netherlands, Denmark, Germany, and also Switzerland was there. And they wanted to harmonize on how you can measure emissions in a barn environment. And it focuses on all these four emissions mentioned before, so dust, odor, greenhouse gases, as well as ammonia. It focused on the one hand on emission measurements inside the barns. It also focused on how can you measure these emission reduction of mitigation techniques, and it involved as well on how you measure emissions applied when you apply manure on the field or on manure storage. These Vera protocols, you still can consult them. They are available online. However, this initiative has been stopped in 2022. But we see that things are changing in the field of emissions. So what now? What in 2025? Well, in 2025, our team, together with researchers from the Netherlands, had retaken this initiative on, okay, how can we measure emissions? And therefore, there are these guidelines. I will explain you later on what's in there. But now let's go over the different partners that are involved in these guidelines. The first one is Wageningen University. It is from the Netherlands, and they have a similar research topics as we. They also focus on emission measurements in barns. Yeah, then there's ILVO. Then there's TNO, which is technology and science organization from the Netherlands. They want to create impactful innovations for the sustainable well-being and prosperity of society. Then the last one is VITO, and VITO is a science to technology partner assisting companies and governments in their transition to a sustainable future. The group of VITO who is involved here has a knowledge on quality control of measurements and also on how to measure gas concentrations. The group of TNO involved here is focusing on how you can measure emissions surrounding the barns. Okay. Now, why these guidelines? The biggest motivation is there because the way to how emissions are measured now is continuous measurements. In the Vera protocol, it is described how you can measure discretely. It's you measure a whole year, but within this whole year, you just measure several days to have an emission for this whole year. So here we focus on continuously measuring emissions, and this is also out of interest from the government. So from the government of Flanders, it is the Department of Environment who assigned us now a feasibility study. Can we measure emissions continuously inside a barn? And from the Netherlands, the government is also of great interest, and here it is the Ministry of Agriculture, Fisheries, Food Security and Nature, and they are in the Netherlands. They are in the transition phase that now a farmer can also illustrate his emission through continuously monitor the emissions, and there's a certain threshold set, and this farmer cannot cross this threshold. If he cross it, he should adjust his management, so the total emission over this year will be reduced. This is the what's inside the guidelines. So we have part A, which is focusing on how to measure emissions inside a barn. We have part B, which is focusing on how to measure the emission reduction potential of a mitigation technique, especially for air scrubbers. So techniques you have when the air is at the exhaust. Then part C is focusing on how you can measure gas concentrations continuously. And part D, which is very important as well, is on how can you validate your sensors or your measuring system that it can measure, that it measures continuously, that it doesn't drift, etc. Then part E and part F, they are included, but if you check these guidelines, these pages are just empty. It is it is with all the goodwill that in the future there might be some work on how to measure dust particles as well as odor emissions continuously, but for the moment we lack the knowledge. If we then compare with the Vera protocols, part A and as well as part B, there's a lot of similarity with the Vera protocols, except that Vera is it has discrete measurements, while here we aim for continuous measurements. And what is not inside these guidelines is when you want to measure outside the barn. For instance, when you apply manure on the field or when you apply mitigation techniques for reduction of emission from manure. Okay, now the status of these guidelines. So for part A and part B, there has a lot of discussions ongoing to the different partners, and the guidelines have been open to the public, to stakeholders, to other researchers, and now there's a lot of feedback that has been unchecked, and the guidelines are adapted or adjusted to this feedback. Then part C and part D are in the revision stage, and here there still needs on a consensus or with the different partners that are writing the guidelines. And then the parts on dust and odor is still future work, so it's not it's not for the moment, but also in literature there's it's for future, it's in the future on the long term. Okay, I want to zoom in on one part, which is the validation, because here at ILVO we have an ongoing project as well. Let's think back about our farmer Joe with his considerations on what ammonia sensor should be. It should measure continuously. It should be accurate, affordable, and withstand barn conditions. So with these 4 requests, we contacted several companies in Europe, across Europe. It are through our contacts or contacts from contacts that we contacted over 90 different companies who are producing ammonia sensors. From almost 60 of them, we got a response that they are interested in because we explained them the project and our goal. Then we checked, do these criteria met with what the farmer Joe wants? And from these 23 sensors, eventually we selected 7 sensors that we are now investigating on. Do they fulfill all these requirements? Okay. Now, here are some details on the sensors. So I mentioned we have 7 in total. 5 out of them measure based on electrochemical sensors, and the 2 out of them are based on lasers, where the signal is magnified through photoacoustics. The sensors also differ in the way on how they sample the air. You have passive sensors which are just hanging there, and they measure the ammonia concentration directly in the surrounding of the sensor. All the passive sensors here are electrochemical. Then you have the active sensors, which are 3 out of 7. So 1 electrochemical and 2 laser-based sensors are active sensors. And here, what I mentioned with an active sensor is that they have an internal measuring cell that they actively take out air from the environment. They measure the concentrations inside the measuring cell, and then it's a continuous flow inside the sensor as well. The last sensor you see here depicted on the right is the Picaro device, which we used here as a reference to validate the different sensors. Okay. Now you can see here our setup where we evaluated the sensors in a short-term test. So it was almost a week that we hang these sensors almost on the same spot. You see the plank with different sensors on it, and also a tubing system which is leading through to the active sensors and also to the Picaro device. Here you see the results. So on the graph on the left, it's a time series. So you have the time on the x-axis and you have the ammonia concentrations on the y-axis. You see that the reference, so the gray line, and then there's some sensors. I only mentioned 2 here, but if I would put all the 7 sensors here, you have similar results. They all follow the same trend. If we then check the plot on the right, so for the linear regression, you have the concentrations measured by the reference as well as the sensors. You see they do not align, but you have some linearity. So this means that we are able to calibrate these sensors to adjust their concentration measurements. Okay. We do not only measure in a dairy cattle barn, we also measured in the poultry barn and as well as in the pig barn for a short period. And then just to illustrate some results in the pig barn, which are in line with what we've seen before. So the time series is following the trend. All the time series of the sensors is following the same trend as the reference. And if we then take a look at the linearity between the reference and the sensors, there is linearity, so we can calibrate the sensors. Okay, so this was it on the long term, but yeah, it doesn't say that much. 1 week, what is 1 week if you have 1 year, or if you want to measure 24 hours, 7 days. So therefore, we now hang the same sensors in a poultry and a pig barn, and it started last year, and they will hang there till the middle of June this year, just to check do they measure good continuously, is there some drift, etc. And we included a continuous reference as well. So as a Picaro on the short-term test, we also included some discrete tests, which is then referring to the Vera protocol. Because here you only measure a couple of days across the whole year. How does this agree or with what we are measuring a whole year with these different sensor devices? And these results of the long-term tests will also be a new insights that we have, and that we can write in part D on the validation of the sensors. So if we then come back to our farmer, is it possible to have such a sensor that measures continuously and that is affordable and accurate? Well, there are sensors available on the market, but what we want to stress is that you want to also validate these sensors. Does they measure accurately, and does they keep measuring accurately? Okay. Yeah, these measuring will be part of the guidelines of our and now I want also a shout out to all of you. If you have inputs or thoughts on these guidelines, please reach out to us if you want to write. If you want to write also with these guidelines, because it's not now, but we also want an English translation of these guidelines. Now they are in Dutch, but we want to open it to all the researchers later on. Okay, thank you.
Okay, so thank you very much, and it was really clarifying, I think, and a very good example of the collaborative work and working together for the same aim. No, so I think it's a perfect example. So I encourage anyone who wants to support this or provide some inputs. That's very good. So I was about to ask about the language availability. So you clarified that, because I think it's really important to make it available for everyone, so we can use it as an example and work together towards this harmonization.